Okay, this is arguably the harder kind, is when there are three variables, but they end up in infinitely many solutions. So the process starts out the same. Looking at this, eliminating z looks the easiest, because if you look at the z's, they're all ready to go ahead and eliminate out. So I'm just going to go ahead and do equation 1 plus equation 2. It's ready to go, and it's going to make the z eliminate. So I have x minus y plus z equals negative 3. X minus y minus z equals negative 3. So that creates 2x minus 2y equals negative 6. We are now calling this equation 4. Okay, we need to use two other equations to also eliminate z to make an equation 5. So it looks to me like equation 2 and equation 3 are ready to go without any multiplying to make the z eliminate. So equation 2 and equation 3. All right, so I get 6x minus 6y equals negative 18. That new equation is equation 4, sorry, equation 5. Okay, so now remember my process then is to take those two equations and to try to get a variable to eliminate. So what I'm going to do here is I'm going to take, let's see here, if I want the, let's say, x's to eliminate, then I'm going to take equation 4 times negative 3. And that will give me negative 6x. And then hopefully the x's will eliminate. So take equation 4 right here times negative 3. That's going to get me negative 6x plus 6y equals 18. And then equation 5 was 6x minus 6y equals negative 18. Now what happens is both x and y eliminate, and 18 minus 18 is 0. Notice that all the variables eliminated and that 0 does equal 0. Therefore, it's infinitely many solutions. Now, if you could just stop there, that's not too bad. But we need you to go ahead and explain what the infinitely many solutions would be. So basically, infinitely many solutions does not mean that that every single number out there is a solution. It means that the number of solutions goes on forever, but it doesn't mean if I just pick 1, 2, and 5 that that's a solution. It might be, but it might not be. So what we're going to do is we're going to create equations that tell us what the solutions may be. So I'm going to take either equation 4 or equation 5, and I'm going to solve for one of the variables. I'm going to choose equation 4. So what I'm doing is I'm taking equation 4, and I'm going to solve for x equals. I want to rearrange it. That's what I'm going to do right here, okay? So I'm going to take 2x minus 2y equals negative 6. I'm going to rearrange it to where I'm going to add the 2y over there. So it could be negative 6 plus 2y, or it could be 2y minus 6, either way. And I'm going to divide by 2. So I get x equals y minus 3. Okay. And I could go about this, and I could have solved equation 4 for y equals. All right, you can do it. It should tell you what it wants, but if it doesn't, you can just kind of choose. So it should say like solve and put it in terms of y. That's what I'm doing here, where all my equations are with y. But it could say solve and put in terms of x. You just do whatever it says. So if I did that, what I found is that x is y minus 3. Y is just whatever y is. And now I'm going to also find z. So what I'm going to do is I'm going to substitute y minus 3 in for the x into one of the equations. I'm going to do it into, I think I'm going to do it into equation 1. It doesn't really matter, equation 1, 2, or 3. So if I do that in for x, instead of x, I have y minus 3. And then I minus y plus z equals negative 3. I literally took equation 1, and right here, I put y minus 3. Now go ahead and simplify that. So that gets me, let's see here, y minus y cancels out. So you have negative 3 plus z equals negative 3. Add the 3 over, and you get z equals 0. So basically what this is saying is that if you were asking what the answers are, just as some sample answers, if y was, just pick a number like 2, z is 0, and x is the y value minus 3. So 2 minus 3 is negative 1. That is a sample answer. Or let's say you chose a y value of 10. Z is 0, and the x value is y minus 3. 10 minus 3 is 7. So that's how you can find out, like, just these are different solutions to this. But this right here, how we wrote y minus 3, y, and 0, this would actually be our answer that we're looking for. Okay, on this one, we're going to let x be the number of seats in section A. We're going to let y be the number of seats in B, and we're going to let z be the number of seats on the lawn seats. Okay, it says the amphitheater charges $75 for A, $55 for B, $30 for a seat on the lawn. It also says that the total revenue, if you sell all the seats, is $870,000. We're going to use those numbers to create an equation that deals with how much money the theater brings in. So kind of a money equation. So 75 times seat A, $55 per seat in section B, $30 for each lawn seat, which we were calling Z, and equals $870,000. Now remember, X, Y, and Z represent how many seats there are. So now another one we can do is the revenue from selling all 23,000 seats. This just told you how many seats there are. So X plus Y plus Z, meaning all the sections, equals 23,000. That's how many seats are in this amphitheater. Now, last but not least, this is always the hardest one. There's always just a third equation that you have to really think about. There are 3 times as many seats in section B as in section A. Now, everybody wants to sit here and go, okay, 3 times the seats in B equals A. But that's not quite right. Here's section A. Section B is 3 times bigger. So you're taking A times 3 to get to section B. So you need to do 3 times X equals section B, which is Y. Now, we prefer to rewrite this in a different order. So what we want to do is we want to subtract the Y, and that gets it to where it's in the same order as the others, which was X, and then Y, and then Z, and then equals a number. So that's helpful. Okay, now we can go from here and we can try to eliminate things. So this equation can be either order. I just put them in both orders so that I can decide which one's useful as I go to solve. So honestly, since I already have y equals 3x, I think substitution would be a pretty good way to go. So what I think I'm going to do is I think I'm going to first substitute in y equals 3x in equation 1 and equation 2. So I'm going to call this equation 1 and equation 2, and this is equation 3. All right, so if I do that, then in equation 1, I have 75, and then x plus 55, and instead of y, I'm putting 3x plus 30z equals 870,000. And if you go ahead and simplify that real quick, that's 75x, 3 times 55 plus 75 is 240. So what I did was I added these together. Plus 30z equals 870. Okay, that's my equation. I'm going to call this equation 4. I just made a new equation. All right, let's also do this into equation 2. So x plus, instead of y, we're putting 3x plus z equals 23,000. Okay, that's 4x plus z equals 23,000. Let's call that equation 5. Now, we're trying to solve, so we want to take equation 4 and equation 5, and we want to either get rid of all the x's or all the z's. It doesn't really matter which one we choose. I think I'm going to take equation 4 has 30z, so if I take equation 4 and negative 30 times equation 5, that will get my z's to cancel out. So here's equation 4, 240x plus 30z equals 870,000. So negative 30 times equation 5, that's negative 120x, negative 30z, and then let's see here, negative 30 times 23,000 is negative 690,000. All right, we can add those, and we get 120x equals, and that's 180,000. So divide by 120, and you end up with 1,500. So there's 1,500 seats in section A. Now, take that number and go back in to either equation 4 or equation 5, because now you have x, so you can find z. I'm going to go into equation 4 because the numbers, or sorry, equation 5, because the numbers are so much smaller. And I'm going to solve for z. And so this tells me that z is 17,000. Okay, now you have x and z. I'm going to go, I like equation 2 right here because there's not a lot of coefficients. And so I'm going to go and I'm going to say, well, now I know x. I don't know y. I know z. And the total was 23,000. And so I can solve for y and find out that y is 4,500. And so what that tells me is there are 1,500 seats in section A. There are 4,500 seats in section B. And there are 17,000 seats in the lawn. And that's my answer to this word problem. That was kind of a combination of like a little bit of substitution right at the beginning right here to make these equations, then a little bit of elimination to actually solve. So that was kind of an interesting approach.